Okay, as I promised, I'm going to put together this video working through some of these problems. These are the Chapter 4 practice problems that I gave you earlier. There is an answer key posted on Canvas with the rubric and all that jazz. You're going to have a test Tuesday or Wednesday. But for the test, you don't have to show all your work. Okay, but it's hard to solve these problems just punching numbers in a calculator. It's better if you write it down on paper, scratch paper for the test. Then you can see that you're doing it right, set it up right. Then all you got to do is enter the numbers in your calculator. You should get the right answer. Okay, first one here. What is the mechanical energy of a 0.15 kilogram baseball that is 30 meters above the ground and is moving at 12 meters per second? Let's check this out. Okay, for mechanical energy, we know that ME equals KE plus PE. So I just write that down. Okay. Then we're going to break that down more. Mechanical energy is equal to the kinetic, which is 1/2 mv squared plus mgh. All right, this is your kinetic energy. This is your potential energy. Okay. Well, you might ask yourself, what the heck is m? What's v? What's m? What's g? What's h? All right. Well, those come from our problem statement. This is our mass. Okay. Kilograms is mass. 30 meters above the ground, so that's my height, and it's moving at 12 meters per second. Well, meters per second is a velocity. Okay, so let's make a little table over here. All right, we're trying to find ME, big question mark, we don't know what that is yet. My mass is 0.15 kg, and velocity is 12 meters per second. Okay, I've already got the mass here, so G, let's write down G. G is always the same, 9.8 meters per second squared. And H is 30 meters. Okay, I just take those values, all right, take M, the value for it, number in unit, plug it into your equation. Take the velocity, number in unit, plug it into your equation. Okay, so on and so forth. So let's write it all out. ME equals 1/2 times my mass, which is 0.15 kg, times my velocity, which is 12 meters per second. I'm going to square that thing. And then I'm going to add mass times gravity times height. 0.15 kg for mass, 9.8 meters per second squared, gravity, and height is 30 meters. Okay. If you looked at those gizmos, it'll give you some ideas on mass and gravity and height. All right, now I'm going to do these numbers on my calculator. I'm going to do this part first, and I'll write this part second, and I'll put them down. So, first part, 1/2. You can do 1 divided by 2, or just enter 0.5 times 0.15 times 12. You got to square the 12. Okay, that's going to be 10.8, and that's joules, because a kilogram times a meter squared over a second squared would give me a joule. Now the other side is 0.15 times 9.8 times 30. That's 44.1 joules. Okay, then you just add those together. So my total mechanical energy is 10.8 plus 44.1, be 54.9 joules. Okay, and a problem. All right, let's move on to number 2. A 4 kilogram rock has 60 joules of kinetic energy. What is its velocity? Okay, this one's a little tricky because we got to find velocity. We have kinetic energy here, so we're going to use the kinetic energy equation. We're not looking for mechanical or potential. Ke equals 1/2 mv squared. Make sure you memorize these equations, okay? Well, Ke equals 60 joules. It's given to us. Mass is given to us. It's 4 kilograms. And velocity is the question, right? That's what we don't know. We got to find our velocity. Taking a break while I get some new pencil lead in my pencil. There we go. All right. So let's plug these values into the equation, and we'll have to rearrange and solve for v. Okay, 60 joules equals 1/2 times 4 kilograms times V squared. All right, now you can think of that as, if you want, that's equal to 2 kilograms, right? 1/2 times 4 would be 2. I'm just going to rearrange everything and put 60 joules over 1/2 times 4 kilograms. This thing's going to be the square root, and that will be equal to V. So my V is going to be, what I do, I enter a 60 in my calculator, divide by 0.5, divide again by 4, because it's on the bottom, so multiply. You need a 30, that number, and then the square root of 30, I'm having calculator issues, is 5.47 blah blah blah. Let's say 5.48 because it rounds up. And that's meters per second. Okay? Alright, what's the height of a 12 kilogram rock that has 90 joules of potential energy, right? We're looking for potential. So let's write PE equals mgh. That's our potential energy equation. PE equals 90 joules. Mass is given as 12 kilograms. We don't know the G, it's not given to you, but we know, we've memorized, that is 9.8 meters per second squared. And finally, my height is unknown. All right, we're solving for the H. Let's plug these guys into our equation. 90 joules equals 12 kilograms times 9.8 meters per second squared times H. That's an H. Okay, 90, well, I'll go ahead and rearrange this. 90 joules over 12 kilograms and 9.8 meters per second squared. Okay, when things are multiplied together, I need to separate them from your variable, H. What we have to do is we have to divide these to the side. So I've got 90 divided by 12 and divided by 9.8. Okay, both of these are on the bottom, so both are divided out of the 90. That's equal to H. Use your handy dandy calculator. 90 divided by 12 divided by 9.8 equals 0.765. Okay, meters. All right, there's your answer. There's my answer on that one. And there's my answer on that one. Okay? Now, when you go through the test, I'm going to round off the answers. So just find the one that's the closest to what you're looking for. Okay, you may put these numbers in your calculator, get some really long decimal. You're not going to find that on there. Okay? Let's round it off. Just pick the right answer. Okay. What is the potential energy of a 5 kilogram rock that is located 60 meters above the ground? All right, this one's pretty simple. We know we're looking for potential energy, so let's write PE and the beautiful formula of mgh. Okay, the formula is beautiful, maybe my handwriting isn't. PE equals, I don't know, question mark. Mass equals 5 kilograms. G equals 9.8 meters per second squared. H equals 60 meters. All right, so all you do is plug those numbers in. Okay, back from our little break. Mass entered, gravity entered, height entered. So you do 5 times 9.8 times 60, and it's 2,940. All right, there's your answer. Okay, next one. What is the kinetic energy of a 0.02 kilogram projectile moving at 1,350 meters per second? Okay, kind of like a rifle bullet or something. KE is what we're looking for. So let's write KE equals 1/2 mv squared. All right, KE equals question mark m equals 0.002 kg, and V equals 1350 meters per second. Right? Things really move fast. Okay. So all I have to do is write these numbers into my equation. Ke equals 1/2 times my mass times my velocity. And the velocity is squared. Okay, when this 2 is on the V, this whole thing in here inside the parentheses is your V. Okay, it's got a number and it's got units. We're going to square the number and the units. Okay, on your calculator, all you do is you square the number. All right, so I'll do 1/2 times 0.002 times 1350. Hit squared on the 1350, and it'll calculate your KE for you. And it's 1820, 2.5 joules. All right, maybe I'd round that off to 1823. Either way, you'll find the right answer. Okay. All right, that was pretty quick. We did 5 in 11 minutes. Takes a lot longer when you got to talk to them. Okay, other side. What is the kinetic energy of a 0.33 pound basketball moving at 60 feet per second? Okay, we know we're looking for kinetic energy, just like on the last problem. So let's write down our equation to start with. Okay, and over here, I'm going to write KE equals question mark, mass equals 0.33 pounds, and velocity equals 60 feet per second. Now, one thing that's really different on this problem is I've got pounds and feet per second. If I just put those in here, I'd get feet squared over seconds squared, and I'd have pounds. I would not end up with joules for my units. So to calculate your answer in joules, you need to convert this to kilograms and convert this to meters per second. Well, each of these only requires one step. So let's draw our little TIE fighters for our one-step conversion. Okay, I've got pounds here. I need something. I need to put pounds on the bottom to cancel it out. I need kilograms on top to get kilograms. I know that 1 kilogram is equal to 2.2 pounds, so I can write this here. And this whole thing in parentheses represents 1, right? 1 kilogram over 2.2 pounds is like multiplying by 1. I'm not changing the value of my mass, I'm just changing the number in the units. Okay, those two things weigh the same amount. So 0.33 divided by 2.2 will give me 0.15 kilograms. Okay. And then, let's see, I got to get feet changed to meters. So feet goes on the bottom, meter goes on top. And I know that 1 meter is 3.28 feet. All right, you're supposed to memorize that. So 60 divided by 3.28 equals 18.29 meters per second. Okay. All right, so now we'll take these guys that we calculated and plug them into my kinetic energy equation over here. So KE equals 1/2 times the mass, 0.15 kilograms, times the velocity, 18.29 meters per second, and the velocity is squared. So square your 18.29. All right? So 0.5 times 0.15 times 18.29 squared will give me kinetic energy of 25.1 joules. Okay, there we go. All right, what is the potential energy of a 175-pound skydiver with an altitude of 2,500 feet? Okay, good question. We're looking for potential energy. First thing to do is write down that equation. That way you don't forget something when you're trying to solve the problem. All right, PE is what we're looking for. It gets a question mark.